Alright, good morning. My name is Captain Dan Newell. I'm an EM 384 instructor here at the Department of Systems Engineering at West Point. And so what I'd like to do with this video is go over our oil exploration PE that we did in class. And so this problem had three parts. The first was part A, asking us to draw a decision tree and calculate what the expected value is. Part B asked us for what the expected value of perfect information was. And part C asked us for the expected value of imperfect information. And so I've taken all of the data and given information from that problem and I've put it in Excel here, which is where we'll be working for this tutorial video. And so let's refresh ourselves first on what the problem is asking. So we've been given mineral rights on a piece of land that we believe may have oil, and there's a 10% chance that we'll strike oil if we drill with a payoff of $200,000. But it costs us $10,000 to drill, and our alternative is to not drill at all, in which case our profit is zero. And so part A is where we'll start. That's asking us to do a decision tree and what is the expected value and should we drill or not. And so again, I'll be doing this in Analytic Solver using their decision tree platform. And so the way we do this is we go up to decision tree and we want to click node and add a node. And so we know from class that we always want to start with a decision node, and we can input all of our data in the dialog box, or we can simply click OK and edit it here directly on the tree itself, which is actually what my preferred method is, so I'm going to do that here. And so with this problem, we know we've got two choices for our decision, that we can either yes drill or we can not drill, which we'll just say not drill. And so you'll want to label your decisions in some fashion to clearly indicate what your decision is. And so in this case, we can yes drill or we can not drill. And so we know if we do drill, there's some uncertainty involved. So I'm going to add a new node, and I'm going to add that event or chance node now. And so what I can do here again is edit it in the dialog box, or I can do it directly on the tree. So if we drill, there's a chance that we will strike oil, so I'll call that yes oil, and there's a chance that there's not going to be any oil there, so I'll call that no oil. And the problem tells us that there's a 10% chance that we'll strike oil, which means there's a 90% chance that we will not strike oil. And so with decision tree, you can see we've got these zeros here right outside each of our decision paths. And so those are where you can input whether there's a cost or a value associated with your decision, which in this case we know that there's a $10,000 cost for us to drill, and there's zero cost for us to obviously not drill. And so if I put that 10,000 in, we can see that it carries through the remainder of the tree. And so all that's left for us to do now is to put in our payoffs, which we see Analytic Solver has three values here for each of the paths. And so I've said in my class to stay away from these two because, as you see in the formula bar, there's associated formulas in those two, and that you want to edit the furthest left. So that would be these two zeros. So if we drill and there is oil, we know we get a big payoff of $200,000. And if we drill and there's no oil, we know we're going to get zero, which we can see that our $10,000 cost appropriately carries through. So we've got final payoffs of $190,000 if there is oil and we drill, negative $10,000 if we drill and there's no oil, and zero if we don't do anything. And so another helpful thing that Analytic Solver can do, as we've learned, is we can highlight the best route or the best path. And so we see this is path 1, which says to yes drill with an expected value that's already calculated for us of $10,000. And so really that answers all of part A. Yes, we should drill. There's an expected value of 10,000 as shown here by the highlighted path. So that's part A. So let's look at what part B is asking. Part B is saying calculate the expected value of perfect information. And we know expected value of perfect information is where we've resolved all of the uncertainty prior to the decision. And so really that involves moving this chance node in front of our decision node for whether or not to drill. So we're going to know yes there's oil or no there's not oil prior to our decision to drill. And so we've got to do that on a new tab. And so I'll do that now, where all you do is recreate the tree, except this time I'm going to start with my chance node. And so everything is still the same. My uncertainty is yes oil or no oil. My probabilities are still 10% for there being oil and 90% of there not being oil. And then I will make my decisions follow second. So I've got my decision node. My decision has not changed. I can still yes drill or not drill. Now, an interesting thing about Analytic Solver is that you can copy and paste nodes to save some time. It's just a time-saving technique. You can go to node and you can copy that node. You see I'm highlighted here. I go to node and I copy that node, and then I can simply paste it down here to save some time. Now, be careful when you do this. You've still got to adjust your payoffs and you've still got to adjust your probabilities as appropriate. And so I'll do that now. So yes, if there is oil and I drill, I know that my associated payoff is 190,000. I know that if there is oil and I don't drill, my payoff is going to be 0. I know that if there's not oil and I drill, I'm going to lose my $10,000 for my drilling cost. And if there's not oil and I don't drill, I get 0. So now I've got the same correct payoffs, and I can then again use the highlight function to see what I should do. And in this case it makes sense. So if yes there is oil, yes I should drill. If there's not oil, I should not drill. That's what this is showing. And that intuitively makes sense. And we know we've got an expected value with this perfect information of 19,000. So now we want to calculate the expected value of perfect information. And so we know that the formula to do that is the expected value with minus the expected value without. So I like to just create some headers there for me to prompt this. And so I know my expected value with, I'll just reference that as 19,000, and my without is what I had here in my original tree, where I did not have the information for whether there was oil or not. And now my expected value of perfect information is simply the difference between those two, which I see is 9,000. So this is telling me that, hey, knowing whether or not with certainty there's oil or there's not oil prior to my decision to drill or not is worth up to $9,000. So I should pay up to that full $9,000 for that information. And so that's the answer to part B, with this associated tree to support how we came up with our EVPI. So now we've completed part A and part B. Let's go ahead and look at part C, which is where I think a lot of the confusion came in last class. And so let's go through what part C has given us. So before we drill, we can consult a geologist who can assess the promise of this land. She can tell us whether the prospects are good or poor. But she's not a perfect predictor. She's okay, but she could make a mistake. If there's oil, there's a conditional probability of 95% that she'll say the prospects are good. If there's not oil, there's a conditional probability of 85% that she'll say poor. And so we're asking you to make a decision tree that includes this consult the geologist alternative decision. And so we can be careful, we give you a hint here, to be careful to calculate the appropriate probabilities in the decision tree. And finally, to calculate EVII, and then if she charges $7,000, what should we do? So we see we're given a decent amount of information, and as I said in class, that usually you're going to need multiple tabs for EVII because you can only do one decision tree per tab. And so the first step is to build your original tree with your given chance nodes. And so in this text, we're given 2 chance nodes, which we should start by building as our first step. And so we know the first chance node is still whether or not there's oil. And I'll delete some of these extra rows just so we can still see the text while we build this tree. So the first is yes, there's oil, or no, there's not. No oil. The same uncertainty that we've been dealing with for this whole problem, and we still know that there's 10% and 90%. Now we see the text says if there is oil, there's a conditional probability that she'll say it's good. So we know yes, there is oil, we've gone up this path. We know we've now got to add the uncertainty of whether or not she's going to get it right and say good, or whether or not she's going to get it wrong and say poor. And that probability is 95% chance that she'll say good. Now, notice that when my probabilities do not add up to 1, Analytic Solver returns an NA error to help you know that, hey, you've got a problem here with your probabilities. And so if we're given the 95% good route, we know that 5% for the poor route, so they can add up to 1. And so now I can copy and paste this node just to save a little bit of time. But again, I'll be careful to make sure I adjust my probabilities appropriately. So let's do that now. If there's no oil, the conditional probability is 85% chance that she'll say poor. So we go down the no oil route, there's an 85% chance that she'll say poor. So I need to change that to 85, which means there's a 15% chance that she'll say good. So this now is our original tree. We've got the two uncertain nodes in the appropriate order based on the probabilities that were given to us. And as I said in class, now we're going to go through the process of using Bayes' theorem to actually get the probabilities that we need in order to calculate our complete tree and figure out what our EVII is. And so in class I said that we kind of do multiple steps, and step 1 is where we just calculate the joint probabilities of the path. So the joint probability of this path, for example, yes, oil, and good, is going to be a multiplication of both of the probabilities. So yes, there is oil, and she says good. That probability is a little less than 10%, and we see it's 9.5%. Let me zoom out and kind of reorient ourselves here. So 9.5% for this path. Now what we can do is just complete the rest of these 4 paths, their joint probabilities. And so the way I like to do that is to just copy and paste and then fix what the cells are referencing. So for example, this is yes, oil, and poor is 0.5%, and you can go through and do the same thing. You can obviously type these in, or you can just copy and paste and make sure that you're referencing the 2 appropriate probabilities. And so here's our 4 joint probabilities. And the way I like to do this is just to do a quick sum to make sure that all of my path probabilities sum up to 1, which is what they do here, 100%. We've got 9.5, 0.5, 13.5, and 76.5. So that's step 1. Now step 2 is to simply rearrange the tree by flipping the uncertain nodes. So I'm going to put the good poor node prior to the yes oil no oil node. So again, I've got to do that on a new tab, and so I'll do that now, where all I'm going to do is build the tree in reverse. So I'm going to start with the good and poor uncertainty, followed by the yes oil no oil uncertainty. Here again, I'll copy and paste the node just to save a little bit of time. And so now I've flipped the tree, but I've got all incorrect probabilities. And so I can either leave in these 50% placeholders, or I can choose to delete them out to know that I need to fix all those by completing the remainder of the steps. So really this is the process of going through Bayes' theorem to figure out what these appropriate probabilities are that we'll use for our final tree. And so in class I said that step 2 is to rearrange my joint probabilities appropriately. And so I'll do that now by using our original tree and just putting them in the new correct order. So let's do that. So the good and the yes oil is the same thing as the yes oil good path. So that's 9.5. So I'll just write in 9.5 right here. I like to have them centered. Here's 9.5. So now let's look for the good no oil path, or the no oil good path. So we see that it's not up here, it's actually down here. No oil good is 13.5. So this good no oil path represents 13.5. Now we need the poor yes oil. So I go back, I see the yes oil poor 0.5. So I'll put the poor yes oil path 0.5%, which leaves me with the poor no oil and no oil poor 76.5. 76.5. So all I've done is I've rearranged my tree, I flipped it, and now I've put the associated path probabilities in the appropriate order. And so we see that the 9.5 and the 76.5, the top and the bottom, are actually the same, 9.5, 76.5, but these middle two, 0.5 and 13.5, have actually flipped. See, so we need to just be careful that we've got the appropriate paths listed. And so step 3 is to just sum those joint probabilities. Sum the joint probabilities, which we'll do now. And so we see that the good is the sum of the yes and the no oil. Yes oil, no oil. The good is going to be the sum of those two, which is just these 9.5 and 13. So what I like to do is put it somewhere in the middle. I can sum that 9.5 and that 13 to see that the good is going to be 23%. Both of those add up to 23%. So I can reference that 23% right here. Now I know that the good probability is 23%. And so I do the same thing for the poor. The poor is just going to be the sum of the two options that the poor has, which is 77%. And that makes sense because this 23 and this 77 need to add up to 1. Good. So now all that we've got to do now is find out what the conditional probabilities are. So I'll make a header. You can totally do that or feel free not to. But essentially what we're doing now is figuring out, okay, if it's good, what's the probability of yes oil? If it's good, what's the probability of no oil? And so we know that it's just going to be a percentage of this total. So 9.5 of 23%, is almost about half, a little bit less than half. And so the way to figure that out is just 9.5 divided by my total, and I get 41.3% chance. So there's a 41.3% chance that if she says good, yes, there's actually going to be oil there. So that gave me a lot of decimals, but I'll fix that later. And so now we need to do the other one. So 13.5 of 23 is a little bit higher than half, right? So it's probably going to be about 58% because it needs to still add up to 1 with my 41%. And so we see 58.7. And so we'll reference that again. So now we see there's a 58% chance. If she says good, there's still no oil there. And so we need to do the same thing for our final two conditional probabilities down here. So we do the same method, just seeing what percent of this sum total each one individually is. So we see this one's going to be the bulk of it. 76 over 77 is almost 99.35. So I'm going to reference those because the decimals actually become kind of important with your final answer here. So you don't need to show all these decimals, but you probably should reference the cell to be a little bit accurate, or at least go out to 2 to 3 decimal places. And so I'll show these decimal places as well. So now I've flipped the tree and I figure out what the appropriate probabilities are in this order of tree. And so now all I've got left to do is to include this geologist uncertainty. What's she going to say? Geologist. The geologist, what's she going to say? I include this part of the tree in my overall tree. And so here's my third tab where I need to include this new information of consulting the geologist. So you can make a decision to consult her or not, or you can go straight to the uncertainty of what she's going to say. So I'll just skip to that now for the sake of time. So geologist is going to say good or poor, and I know my new probabilities of her saying that. I can either reference it or I could just type in 23. I'll reference it for the sake of complete accuracy. So 23 and 77. And I know if she says good, I still have a decision. I can either drill or not drill still. So my decision is yes, drill. My decision is no, not drill. And I know if I drill, I've got some uncertainty for whether or not I'm actually going to strike oil. So I'm going to make another chance node, just like my original trees. And I'm going to say yes, oil. And I'm going to say no oil. Now be careful at this point. I haven't fixed my payoffs and I haven't fixed my probabilities, so I need to do that. So the yes drill, if I drill, it's going to cost me $10,000, right? But I'm also going to get that big payoff of, I'm just going to put it here, negative $10,000, and I'll put my big payoff of $200,000 appropriately if there happens to be oil. So if she says good and I decide to drill and there is oil, the payoff is $200,000. And if I don't drill, I'm just going to, if there's no oil, I'm going to lose that $10,000 drilling cost. But I need to fix these probabilities. So we know that if she says good and there's oil there, that's our flip tree. That's what we were looking for. If she says good and there's oil, that's that 41.30%. So I'll put in 41.30, which means this percent then needs to be 58.7, which is the good no oil path, right? She says good, there's no oil, that's that 58.7 that we found. So then I need to do the same thing for if she says poor. And so I'll do that now, and you can copy and paste this whole part of the tree to save some time if you're in a crunch. Just make sure, again, you adjust your probabilities and your payoffs appropriately. So now I've copied and pasted that whole part of the tree, and I'm going to confirm that everything here is still accurate. So if she says poor and I still decide to drill, I lose that $10,000, but if there is oil, I get that $200,000. Now, are these probabilities still accurate? So let's see. Poor, yes, oil. Poor, yes, oil is actually this 0.65. So I need to fix that, 0.65. And then I need to put the difference, which is this 99.35. So I'll put that right here, 99.35. So now I can see my tree is complete for what the geologist is going to say. And again, I can add a decision, consult geologist, yes or no, and build this tree out further. But really in this example video, I'm just starting with what the geologist says, showing, the tree flipping and Bayes' theorem application. So I think we're about ready to turn on the highlight and see what we should do here. So if the geologist says good, yes, I should drill. If the geologist says poor, no, I should not drill. And so now I've got a new expected value. So my expected value with, expected value without, same method without, expected value without. And my EVII is simply going to be the difference between those two. So I know my expected value with is right here. I know my expected value without is from my very original tree of not having any information. And so I know my expected value of imperfect information is the difference between those two, and I see that it's worth $6,998. So that's great. I've got a benefit of knowing whether she says good or poor of $6,698. But the text, if you remember from the beginning, said if she charges $7,000, what should I do? So if this geologist charges $7,000, I need to subtract that cost out, right? And so I'll see, I'll just say use or not. And I know that the value is worth $6,698, but she charges $7,000. So if I've got it as a negative, I'll just add those two together, and I'll see that I'm going to actually lose $302 if I use her. So my answer is absolutely, even though she provides valuable information, she's charging too much. So I should not use her. So I think that concludes what I'm trying to show with this video, going through part A of just making the original tree, going through part B, which is the EVPI and putting the uncertainty up front, and then going through part C, which is the EVII process, where we've got our original tree, we flip the tree and go through the process of finding the appropriate probabilities, and then we apply that to a complete tree to evaluate whether or not the actual information makes sense based on the cost of that information. And so thank you for watching this. I hope that helps, and that concludes this video.